My name is Noelle Walsh. I am LDM Coordinator at Max 4 Laboratory, and I'm also responsible for one of the LDM end stations at the lab. LDM, or low density matter, is a blanket term used at Max 4 to describe research activities on gas phase molecules and clusters and on liquids and aqueous solutions. At Max 4 we have different types of sample delivery systems. For example, a molecular jet or cluster source for the generation of cold beams of molecules or clusters, a magnetron sputter source for the generation of metal clusters, and 3 different liquid microjet setups for use at various beamlines. In addition, we are also engaged in collaborations with our user community in order to develop new sample delivery systems that will allow us to generate new sample types. Gas phase and liquid experiments require specialised differential pumping between the sample chamber and the measurement chamber. This is to protect equipment in the measurement chamber, but also to protect equipment along the beamline and of course the ring itself. And not every beamline is built to accommodate these kind of measurements. At Max 4, we currently have 6 beamlines that can already facilitate or that will be able to facilitate low density matter research on gas phase and liquid samples. These LDM relevant beamlines are finest beams, FlexPES and species on the 1.5 GeV ring, and Veritas and HIPPIE on the 3 GeV ring. The 5 ring beamlines deliver photons with energies ranging from 4 eV up to 2200 eV. The 6 beamline, FemtoMax, with potential relevance for LDM research, delivers photons spanning the tender and hard X-ray ranges. Both finest beams and FlexPES each have a branch line dedicated to LDM measurements. Between them, these 2 beamlines offer the following types of experimental techniques: high-resolution photoelectron spectroscopy and angle-resolved electron spectroscopy on molecules, clusters and liquids, ion time-of-flight mass spectrometry on molecules and clusters, multi-coincidence and momentum imaging techniques on molecules and clusters. In this case, finest beams offers an electron energy resolved PEPIPICO setup, and the ICE end station, a new mobile end station at Max 4 that is under the final stages of commissioning, will offer access to a cultrons or a reaction microscope setup. Soon, negative ion, positive ion coincidence spectroscopy will also be available at the lab. Another technique of interest to our LDM community is RICS. Resonant inelastic X-ray scattering on gas phase and liquid samples will be available to our LDM users within the coming years. Both species on the 1.5 GeV ring and Veritas on the 3 GeV ring offer access to RICS techniques. The gas phase source that is required for RICS experiments is currently under development. HIPPIE, the second LDM relevant beamline on the 3 GeV ring, offers the possibility of performing ambient pressure XPS using a liquid microjet. And FemtoMax, our 6th LDM relevant beamline, is located at the Short Pulse facility and delivers photon pulses of 100 femtoseconds duration. The beamline also has an 800 nanometer pump laser available to its users, thereby facilitating pump probe measurements. The FemtoMax beamline has an open port at which LDM equipment can be installed. The 1.5 GeV ring also offers another and very new possibility to our wider user community, and that is single bunch delivery. Single bunch operation will be available at the 1.5 GeV ring during a couple of weeks of each academic year, allowing the opportunity for time-resolved experiments at the soft X-ray beamlines. For more information on LDM facilities at Max 4, visit the LDM pages on the Max 4 website.